Okay, students, this is the setup for project number 2. In this project, I want to know how many waterings of this small garden up here at the top. How many waterings can I get from a full single rain barrel? And so I'm going to show you how we can determine that. What we'll do is we'll use this hose right here to water this small garden that I showed you in project number 1 video to determine exactly how many waterings we can get out of this thing. So hang on just a second. So we could start with this rain barrel because we know where the water level is in this one. It's full. And in our last video, project number 1, we talked about where that point is. So we could maybe start with this one, but that's too easy. So let's do something different. Okay, so here goes Mr. Price again doing something crazy. He's put the garden hose, the outlet of the garden hose, which he's going to use for watering, at the top of the rain barrel. Well, the first thing I've got to do, and you've got to do, we got to figure out, well, where is the water level in this rain barrel? We can't look inside and see. There's not a sight glass on the outside, which there is on some tanks. Don't need one on this one. So let's figure out with the garden hose where that water level is. Okay, so here I am at the top of the rain barrel. There's that garden hose. And theoretically, if I lower this garden hose vertically, the water level in the hose will equalize the water level in the tank. It will depict or indicate the water level in the tank, and that will be the point at which water just begins to pour out of this hose. This is similar to a manometer that you use for some differential pressure measurements. Won't go into that, but let's see what happens here. I'm going to lower this. Okay, I'm going to try to do this with 2 hands. And you'll see the liquid level in this hose rise slowly. There it comes to the point where it is at the top of this connection right here. And it is vertical, this hose, so right there is where the water is beginning to spill out. So that is our current liquid level in this rain barrel. So again, this hose has equalized the level in it with the level in the rain barrel. So where I am about to show you on my tape measure here, if I can, the liquid level, it's just pouring out of the hose there, as you can see, but that liquid level corresponds to the top of that pipe connection, which is basically at this point right here. So if we came across to the tape measure, that would be the current level. See if you can see that current liquid level in this rain barrel. So there you got your first measure. Okay, now I'm going to take that hose off of the rain barrel and water this small garden up here, and as I normally would. And then we'll take another second measurement and see how much it dropped, and that would be the vertical height difference for one watering of this small garden up here. So let's see what that is. I'll be back at you in a minute. Another thing I want to calculate is the amount of time that it takes to water. So I'm going to start about 3:16. You can see it on my scratched up watch here. So we're going to start about 3:16. Let's see what time we finish, how long it takes. I want to show you another calculation we can do. I want to show you this. This just gives you an idea how fast the water is coming out. It's interesting. We'll do something on this later, but the lower elevation I go with the hose, the faster the water comes out, the faster the velocity, which is also equal to the flow. There's a physical scientific principle behind that. We'll study that maybe a little later with a different math formula or literal equation. By the way, I stopped watering about 1 minute ago, so that would be 3:29. So it stopped at 3:29. Okay, so after watering, I put the hose, taped it back onto the rain barrel beside the tape measure, and you can see where the water level has now dropped to, which is, you can see it on the tape measure. You can judge it for yourself. I will put my finger there to show you that that water level is at the top of that hose. So you be the judge of where the new level is. So in conclusion here, obviously the difference in the water level in the rain barrel there is equal to the volume that I put on the plants. We also know there was a time difference between when I started and when I ended. So I want you to calculate the average flow, water flow through that hose. And what you would do is, once you find the volume that was used during that watering, divide it by the time. And I want you to give me that volumetric flow rate, average volumetric flow rate, in gallons per minute. And that'll be part of project number 2. Just for your information, the other thing I'll show you is probably a good idea. I came out here to water. I kind of watered this morning, but they were pretty dry. So if you look at these leaves, I don't know if I can get it on my camera or not, but there's a good one there. You can see they're beginning to close up a little bit. They're beginning to wilt. That is the plant's defense mechanism against moisture loss. What they're trying to do is keep as much moisture in the plant as possible and not let it evaporate with the sun. So now that I've watered it, those will probably be able to open up some more. On the underside of this leaf, you can't see it unless we had a microscope here, but there are, they're called stomata openings, and the openings have guard cells that open or close in response to different environmental factors. One of them being excessive heat or water loss. The guard cells tend to close and reduce the amount of moisture leaving that leaf to protect the plant. So that's basically what's happening here. That's biology. That's another course, but now you learned a little something here about another subject. Cheers.